Hello, everyone. This is Tyler. I'm sorry I can't be there in person, but I wanted to submit my own talk to include today, and I hope you all enjoy it. Now, Nina had told me that if I could include something about lizards, I would get bonus points, and with that, I knew exactly what I wanted to talk about. I took an evolution course a while back, and it was one of the most fascinating, interesting courses I've taken, and I want to talk to you about some of the things I learned in that class. One thing in particular, proving evolution. Turns out it's actually kind of hard. So, in the beginning, I know you all have heard about Darwin. He was not strictly, though, a main character from Amazing World of Gumball. He was also a 19th century natural philosopher. Now, I know you guys have actually heard of Charles Darwin, um, but the specifics of what he did are actually really fascinating. So, we all know that he went over to the Galapagos, rode some turtles, and took some birds back home. But evolution in his time was already kind of an accepted idea. You could go out to the beach, pick up fossils, and be like, huh, looks like animals change over time. And Charles Darwin was like, yeah, my dude, and I'm going to show how it happens. Direct quote. So he, on the Galapagos Islands, saw all these various, like, specific niches of the environment that animals were able to either survive and thrive in or die off. And they would pass on those traits, those things that made them do well, to their children. And so over time, the offspring could get better and better at surviving, and as such, nature is selecting what it wants to live in that certain region and certain time. So he was the first one to really kind of talk about that and demonstrate that. Not so much demonstrate, because that's the key. He was able to explain it, show why it makes sense, but he couldn't prove it. He couldn't go out there and do an actual study, and he didn't think you could. He thought it would take far too long, understandably, to actually prove this. So, the first people to actually show in the field hard, tangible evidence with predictable ability the power of natural selection by evolution were this couple here, the Grants, a power couple also out of England who studied finches on Daphne Major in the Galapagos. Um, this book here, The Beak of the Finch, is where I got this story from, and it is a book well worth any and all of your time. A fascinating dive into evolutionary biology and the impact that the Grants had on the field. So what did they do? They were out on this inhospitable spit of land called Daphne Major, a small volcanic rock in the Galapagos that has nothing on it except for cactuses and birds. Plenty of birds for them to study. And what they collected over time was the changes in the birds' beak sizes and the impact of major weather events that caused changes in the availability of various seeds on the island. So certain birds were able to survive and thrive, while others, unfortunately, were not able to carry on their offspring and their progeny. Now, how well were they able to predict which birds would survive and thrive? Here's a quick quote from the book. Many people, even biologists, even today, find the power of slight variations hard to believe. Quote, once, just as I was beginning a lecture, says Peter Grant, a biologist in the audience interrupted me. How much difference do you claim to see, he asked me, between the beak of a finch that survives and the beak of a finch that dies? 1/2 of a millimeter on average, I told him. I don't believe it, the man said. I don't believe a half of a millimeter really matters so much. Well, that's the fact, I said. Watch my data and then ask questions. And he asked no questions. None, Rosemary agrees. And he sat there scowling, fidgeting, and talking the whole time. So, this couple were the first to show hard, tangible proof of how natural selection can cause a species to actually diverge and change over just a few generations. The rapid action of natural selection was something so new. No one had ever even thought that it could occur so quickly. And now, for my bonus points, I want to actually talk about the other more recent study that was also very impactful in demonstrating in hard time evolution and its predictive power. This gentleman here, the dork with the lizard on his glasses having the best time of his life, is Jonathan Losos. He wrote this book called Improbable Destinies, another one well worth your time that dives into specifics of his research and how evolution can actually tell you which species are going to survive in this region and which ones aren't, and which way is nature like tending toward. Absolutely incredible, worth, again, well worth your time to read. But the large study that he did that changed the field was his study of the anole lizards in the Caribbean. Um, he was looking at how these lizards are adapted to specific types of plants on different islands and how they evolved to do so. And to demonstrate some of the work that he did, I have a really cool video I want to show you because it's better than anything I could ever say.
Yeah, these lizards are very cooperative. We begin by comparing the running ability of two lizards.
Short legs, yeah.
One with long legs, the other with short ones. Let's do some tests. Let's start with this little lizard here and see how fast it can run up this broad surface.
All right, I'll catch him if he makes it to the end.
All right, here we go. There he comes.
Wow. She's a sprinter.
Exactly. She lives at the bottom of trees, right in the open. She catches prey on the ground, so she has to run down quickly to get them. The shorter-legged twig lizard is not nearly as fast. It seems like a disadvantage. Why aren't their legs longer? Jonathan puts a twig lizard on a thin branch to demonstrate. All right, let's see how he does. Here we go.
Looks pretty comfortable there.
Yep.
Just sort of scurrying along like a balance beam.
This is what they love. Instead of speed, the twig lizard's legs provide a firm grasp. All right, now let's try the other one.
So this is the sprinter.
This is a sprinter. Let's see how she fares on this little stick. Look how ungainly she is. Her legs are too long for this. So you can see on these narrow surfaces, long legs are a disadvantage.
Cool. So let's talk about what Losos actually did on these islands. So he's studying these anoles and wants to see if they can colonize and how they were able to reach out to all these different rocks, all these different islands throughout the Caribbean. So he picks up a bunch of these lizards and just documents specifically what they are and what they look like, drops them off in pairs on a bunch of different islands. And when he leaves, a hurricane comes through. And unfortunately, when that happens, it sweeps away a bunch of lizards and a bunch of plants. So he realizes in that moment, hey, if I go back there and I start documenting how these lizards are changing from these dramatic natural impacts, maybe I'll be able to see them changing over a few generations. And that's exactly what he does. He goes over there and he can see, like on these rocks where there's nothing but twigs left, the lizards and their offspring are tending and start to develop shorter and shorter limbs, those advantageous limbs that allow them to sprint across the twigs easier and collect more food. Um, Again, another fascinating study, well worth looking into that book. He dives into way more that is so interesting about just like how these species diverged over time, why islands prefer these specific types of lizards, and why every different type of island throughout the Caribbean developed the same types of lizards, even though they're all different. Um, Anyway, thank you all so much for your time. I know I went a bit over, but I hope you appreciated it. I hope I spurned your interest in evolutionary biology. The books, again, well worth your time, and a link to the actual video that I sent from, I'll include in the description. Thank you much, and have a good day.